Hello, everyone, and welcome back to the Mobex Software-Defined Vehicle Connectivity Summit. This is the third of 5 sessions. Here, we'll explore how unified end-to-end security architectures are replacing fragmented approaches in order to better protect connected vehicles and enable scalable, real-time threat detection and response. My name is Will Gerling, journalist at Automotive World. I'm joined by Ish-Shalom, VP of Strategy and Product at PlaxidityX, who will share insights into how integrated car-to-cloud security models can strengthen resilience while reducing operational complexity. There will be time for Q&A with him at the end, so if you'd like to ask a question, you can do so by typing it into the Q&A box on your screen using the little square button with a question mark in it at the bottom right. Without further delay now, I'll hand over to Ran.
Thank you very much. So, welcome everyone. Today, I want to talk about how we are moving beyond the checkbox. Most of you here have fleets that are audit ready. That's how you build them. You wanted to meet your legal requirements. But the question I have for you is, your fleet, is it just compliance ready or is it also attack ready? Right now, the industry, the way we know it across many of our customers that we talk with, the industry is trapped in a compliance illusion. We are paying a premium for a massive data ingestion and very high total cost of ownership because of very large and separate deployments of VSOCs. Yet, we are receiving marginal security value. Why is this happening? Because we built basically a Tower of Babel, from many different Tier 1s ECUs. Your vehicles are basically a collection of ECUs from dozens of different suppliers. Each one of them have their own proprietary security logic, their own proprietary logs, and because these systems don't speak the same language, an anomaly in one ECU, for example, may become a false positive in another, or the correlation of logs from one ECU is very difficult to achieve with another log from another CPU. At the end of the day, you end up with a science project that is becoming very difficult and obviously also very expensive to solve. Everybody is trying to deal with this Babel of Tower of Babel security, trying to merge and trying to correlate between different logs and ending up with something that is barely working. And it's making fleet-wide correlation next to impossible. But oftentimes we also see that even within a single car, it's very difficult to detect a real attack, and you end up with a lot of noise. This fragmentation has led to what I call the 3 hidden taxes of automotive security. First of all, the data tax. You're paying to stream raw, useless logs to the cloud, trying to replicate as much information as possible from the vehicle and correlate that in the cloud. The noise tax were, according to research, 73% of what you're streaming to the cloud are false positives. And then there's the SOC tax. It's basically unsustainable cycle where you have to hire so many people to deal with so many logs that most of them are useless. So in a way, we see a linear connection where you're actually streaming a lot of noise, a lot of logs into the cloud, needing to build very large VSOC deployments with many analysts and Tier 1 or L1 personnel to analyze them. And you're just buying and paying for expensive noise, but you don't get real security. So, let's talk a little bit about the blueprint of modern resilience. And to do so, we need to understand or to build the guidelines of what we want to build. We want to be able to, first of all, get operational ROI, meaning try to get as much security as possible for the minimum possible TCO, total cost of ownership. The idea is to break this linear correlation between the number of vehicles that you have and the size of the SOCs. This is the size of the SOC. This is what I call the SOC tax. The second part is the understanding, and this is basically the way I look at it. This is cybersecurity one-on-one. In order to build an effective SOC solution, or VSOC solution in this case, you must have at least 3 elements. You must have 2 legs within the object that you're monitoring, in our case, a vehicle. One is looking at the endpoints. In our case, again, in the vehicle case, we're talking about the ECUs themselves. Not all of them, but at least the major ones and the ones that are open to external communication. These are the access gates into your vehicle. You also need to monitor traffic to be able to identify a more complex attack where you see lateral movement, where you see how one ECU is trying to impact or manipulate a different ECU. So a network detection capability is also critical. And of course, you need to correlate at the fleet level. Not just one single car, because you want to be able to identify trends. You want to take into consideration your entire fleet and not just each car by itself. And the third element that is critical is, as I mentioned before, you're streaming a lot of data. It's important to understand and make sure that you only stream relevant data. If you'll stream everything that you have, you'll end up with a very expensive deployment that is basically generating a lot of junk data, if you will, ending up with very basic security and having to pay very high prices in terms of SOC personnel, SOC staff that you need to make sure you have enough people to address all the incoming logs and alerts, as well as the transmission costs from the car to the cloud. The more data you send, the more expensive it is. So we need a new blueprint for resilience. Today, I want to introduce PlaxidityX Vehicle Detection and Response Architecture. This isn't just another tool. It's the first ever hybrid car-to-cloud security architecture, and it shifts the paradigm from cloud only to smart edge and wise cloud. And we'll talk about what it really means. The regulatory mandate, where all of us must be able to meet the UNR 155 regulation, the Vehicle Security Operations Center, VSOC, is no longer just a recommended security measure. It's now a strict legal requirement for vehicle type approval. But let's talk how this shifts the conversation from cybersecurity being just an optional add-on to it being a mandatory license to operate. So yes, we've met the compliance target, but let's use that opportunity to make it also an effective security tool. Because at the end of the day, we all know that the cars are becoming more complex, with many more gates opened to attackers and hackers to take advantage of what you have. So we need to make sure that eventually you protect your brand. A car is just a gateway, by the way, to your backend, to your manufacturing floors, to your entire database and your entire organization at the end of the day. It's an easy and very accessible gateway. And the risk of compliance only means that you don't really have security. So we want to get better security at a lower cost, so controlling the cost. Today, budget issues, we all share them. tier ones, OEMs, even the other tier vendors, we all are very mindful of our budgets, and we need to make sure that we try to meet our very strict budgets, but still deliver an effective solution. We also need to keep in mind that the life cycle of a vehicle is about 15 years, 12 to 15 years. So we need to future-proof our solution. Very difficult to tell today what will happen in 15 years from now, which type of attacks will be more common. But you need to be ready, and you need to still protect your car even after 15 years. So let's understand how we can do it, and also talk later on about why just make it just cost effective? Why not make it also a revenue enabler? Let's make money using security, and we'll talk about that. So the beauty of our VDR architecture is that we're using a single architecture to power multiple capabilities. In our case, multiple use case. One is the vehicle cyber protection, which I'll explain later on, but that's the basic VSOC capability. And the other one is keyless theft prevention. I'll explain exactly why theft is very important to us as cybersecurity experts. But we're using the same architecture to support both. This basically eliminates the integration tax and maximize the engineering reuse, making our solution more cost effective. So to solve the compliance illusion, we're moving away from a cloud-only model to the first ever hybrid car-to-cloud architecture. There are a couple of key elements that we're changing in this new architecture. First and foremost, we are creating an architecture that has both a cloud backend as well as an in-vehicle presence. Why an in-vehicle presence is so important? First and foremost, for visibility, but also for stopping attacks at the source. Because the edge is smart, it can trigger an immediate local response, like immunization or immobilization of the vehicle itself, without waiting for a cloud connection, because not always we can ensure that you are connected. And when you only have a backend solution and no presence inside the vehicle, obviously the response options are very limited, if exist at all. In most cases, what we saw with modern car architectures, there are no enough APIs or effective APIs that take security into account. Therefore, you're actually left with a detect-only solution, and that's obviously not good enough. The second point that is critical to understand, that the architecture has to be bidirectional. There's a bidirectional intelligence flow. Upward, basically the vehicle brain, the smart edge, processes high volume signals locally and send only high fidelity signal only alerts to the cloud itself. But there's also a downward stream. The cloud, or the wise cloud as we call it, pushes new detection rules, pushes new visibility configuration and rules to our agents, and also update the agents with new heuristics over time, because like we said, the life cycle of a vehicle can be 12 to 15 years. So over time, it's a long period of time we expect the agents will need to evolve and become more complex and much smarter to be able to address modern threats and even stay ahead of the evolving threats. So let me emphasize a little bit this concept, because I think it's a major element or a key pillar in our hybrid architecture. The it is very central to our architecture, this bidirectional link with the, as I mentioned, the upward flow where we're streaming data to the cloud based on visibility rules that can be dynamic. So maybe today we don't really need to know about the, let's take for example, the speed of the vehicle. But maybe in the future we'll learn about an attack where the speed is one of the parameters that we need to qualify in order to be able to detect a specific attack. So we can dynamically update our visibility agents so that additional information will be shared with the cloud whenever needed. But we also need to be aware that everything we send to the cloud has been processed initially. So we're only sending important information, relevant information, so we can minimize the bandwidth and as a result, minimize the cost of this upward flow. The downward, as I mentioned, the ability to update, change the configuration rules, change the detection heuristics, and make sure that we stay ahead of the threats. It's an ever-changing threat landscape, as you all know. But it's not enough. It's not enough because vehicles are built with a lot of proprietary technology, from unique buses such as the CAN bus to unique protocols such as SAM-IP, DOIP. It needs to be enhanced and enriched in order to be able to leverage the maximum information on the backend side in the SOC or the VSOC. It's important to enrich the incoming information with a lot of elements. For example, vulnerability information. Again, according to UNR 155, at any point during the life cycle of the vehicle, if a new vulnerability is detected, it needs to be reported. But the SOC is the entity responsible for these workflows. So we need to enhance the detection in the car with also a vulnerability feed coming from, for example, a software supply chain security element that keeps analyzing and comparing the SBOM for each and every ECU in your vehicle against new vulnerabilities. And when a new vulnerability is detected, it needs to flow into the SOC and create a new incident that will be handled by the SOC. Another example of an enhancement or enrichment feed could be threat intelligence. How about IP reputation? If you, for example, discover that your vehicle is communicating with a rogue server based on the destination IP, you can then understand that the car is infected somehow and take the measures to address it. So that's another option. Tara. Tara is a major investment during the production phase. You already invested in analyzing all the threats and risks and all the paths into your vehicle. Why not use it to ensure that the severity of attacks takes into account the Tara, understand the potential damage that is possible from this type of attack, and dynamically changes the severity of the incident based on the Tara analysis that you already invested in. So we can also take the Tara into account and make sure that severity is directly changed based on the risk and the threat level as was determined by the Tara analysis. So I won't go into too much detail, but obviously there's a very good reason why the architecture needs to be hybrid, an element or agents inside the vehicle and a backend. There are some elements that are performed better at the back end. So obviously fleet-wide analysis and very deep analysis and correlation that requires a lot of CPU power. That's probably better done at the cloud level. It's also easier to update and maintain, and at the end of the day, it's a critical element of the overall solution. But you cannot forget the in-vehicle agents. They are critical, basically, because first of all, inside the car, you have all the data available to you at no cost because it's already operating locally. You can get and analyze as much data as needed. Obviously, you cannot copy all the data to the cloud because, like we said, it's very expensive. But inside the car, everything is available. You can analyze multiple aspects and decide what has a high probability of a real attack and a true positive, and what is actually a false positive and should not be transmitted to the cloud. It's also, as I mentioned before, critical in the aspect of remediation and response. If you don't have any visibility and presence inside the vehicle, there is no way to close the loop and provide or do any action that will help respond and defer the attack. In addition, if those are high-end agents, in many cases, it's even possible to completely prevent the attack before it happens. And when you do so, well, you got rid of a major headache ahead of time. So I mentioned a lot the need to meet the UNR 155 requirements to build a VSOC and monitor your entire fleet. So I want to talk a little bit about one of the applications on top of the VDR architecture, which is called, we call it Vehicle Cyber Protection, which basically unifies the in-vehicle agents with the cloud to deliver continuous detection and context-driven response. It's a very open architecture because we understand that it's very difficult. You already have an existing fleet. You already have, in some cases, agents already deployed inside your vehicles. And it's very difficult sometimes to change them, at least not during for existing cars that are already on the road. So we wanted to build a very open and flexible system that allows OEMs to adopt security at their own pace. We understand that it's a journey. We understand that you want to get to the best security at the lowest possible cost. So we're starting where it matters most, and we're building together in baby steps, phases where we can take you from where you are today to where you want to be in the future, providing you with better security, much stronger security, if you will, at a much lower cost. So there are multiple elements that we offer, but like I said, it's an open architecture. So if you already have another IDPS that is protecting, let's say, your Ethernet or your CAN buses, we can integrate that into our system, and it will be completely transparent to you as the SOC operators. But we offer multiple layers of analysis inside the vehicle, starting from the sensors themselves, what we call them IDPXs, or IDPS, which is more the technical term, where they provide the monitoring and response capabilities. On top of them, there is another layer of management. We call it IDXM, or IDSM, the technical term, where basically those elements are qualifying security events to make sure that only true positives are sent and analyzed, and reducing the amount of false positives and noise on the backend side. And the reporting agent, which is providing AI-based analysis. It's providing reporting authentication capabilities, basically connecting the car to the cloud in a very secure way. But if you want to look at the architecture itself, as I mentioned, at the vehicle level, you can get any of our agents, management agents, or the reporting agent, or of course the sensors, or use any of your existing third-party agents where we will basically normalize them into our databases. This is basically being done at the backend, where we have in our backend solution, which we call VPCC, Vehicle Protection Cloud Core, we have an element that parses, filters, and normalizes data coming from any third-party source. Yes, it might be noisier than our IDPXs, which won first prizes for being very accurate with almost no, in many cases, completely no false positives. But still, we can filter and remove duplicates and a lot of noise on the back end. Then, once we normalized all the different logs coming from this, as I called it before, the Tower of Babel, once we build unified sets of data across your entire entity, we can then correlate them with out-of-the-box predefined rules, and on top of that, dynamic AI-powered advanced heuristics with anomaly detection and other capabilities that are important to be able to detect 0 days and new attacks over the life cycle of the car. This process, at the end of the day, removes almost immediately 40 to 60% of the junk data between the vehicle and the backend, and the detection engine removes the rest of the noise and ends up with the 1% true positives that are really incidents that someone needs to take care of. It's a critical element in building an effective solution. On top of that, as I mentioned, there are enrichment capabilities such as vulnerability detection. In our case, it's a product called Software Supply Chain Security, which basically monitors binaries of ECUs to generate SBOMs and then compare them to all the vulnerabilities databases out there and alerting on a potentially new vulnerability. Auto Designer is an automatic Tara analysis tool that can take your architecture and dynamically create a Tara that can feed our detection engines to provide dynamic severity. And threat intelligence coming from third parties and many other sources where we can use to enrich the information. Why we do so? Because at the end of the day, we also believe that part of breaking down the silos, it's also about connecting to your existing workflows. You already have a SOC, an IT SOC, and in many cases also an OT SOC. It's wrong, very wrong, to have a separate VSOC. Your vehicle deployment, your vehicle fleet is not a separate element from your organization. It's part of it. And in many cases, you will see an attack that may start at the vehicle and then propagate into the manufacturing floors. If you won't be able to correlate your incidents coming from the manufacturing floors and incidents coming from your vehicle fleet, you will not be able to detect the full story of the attack. If you cannot detect it, you cannot mitigate it. And of course, you cannot prevent it in the future. So it's wrong. It's very wrong to have those silos. This is why we built our solution to basically easily integrate with your existing SOC. The enrichment that we provide to the information and the logs and the incident along the way allow cybersecurity experts who work with data coming from the connected vehicle, same way they work with data and logs coming from your IT, laptops and servers and what have you, or your OT solution. So they don't have to be experts on vehicle architecture. They don't have to be experts on CAN buses. We analyze that. We help provide a lot of enrichment and context so your SOC can manage your connected fleet. So again, you save on staff. It's not a separate vSOC deployment. It's already part of your existing SOC, and you get better security. So again, better security at a lower price point, much more cost effective. As I mentioned, by the way, it's a journey. We understand it's a journey, and we support it. We start from what you have today, the fragmented tools. We call it Security 1.0, sorry. And then we take you step by step, adding capabilities, reducing the overall cost of operating your SOC, and building a better solution for you. Each step can be tailored to what you have, to what you need to meet your goals. Eventually, you will get, in some steps, to what we believe to be the most comprehensive solution, which is the most cost-effective one as well, which we dubbed as Security 3.0. I mentioned that security is expensive, but security can also be a revenue generator. And it's interesting to know that basically security is, or cyber attacks, the first place that we discovered real cyber attacks, they manifested in car theft. Because the car is basically code on wheels, we saw more and more thieves using and leveraging existing tools. You can get them on the black market, the dark web, many outlets. Those tools are available, and they basically are able to override your security protections and, for example, unlock doors and start the engine even without the keys. So we see that it's becoming a major concern of our industry. We see it almost in every country. In some countries, it's becoming an epidemic. It's amazing, for example, in the UK, it's next to impossible to get insurance for Land Rovers because they are being stolen in very large numbers. And thieves are using very small tools that can connect to connectors that are found in, or are very easily accessible from outside the car. They connect a very small tool that it's next to impossible to detect. And this tool basically injects those commands, open, unlock doors, and start the engine. It's called CAN injection tools. We see them more and more. We see thieves using key duplication techniques to generate new keys and take the car. They already have a key. Why not? So we're using the same capabilities and the same architecture, but now we've created a new agent inside the vehicle. That this new agent is looking for a different type of attack, an attack that basically looks okay. These are real commands. Unlock doors and start the engine. These are real allowed commands, but we have ways to detect that they are illegal in the sense that they are unauthorized. They are not performed by the driver or the owner of the car. We detect that, and we can prevent the thief from manipulating this process and stealing the car. And this is what we call VDOM. And again, the attacker is approaching the car and in some way trying to manipulate something inside the car. We detect it with our agent inside the car called TDPX. We report that to our backend. Remember the architecture we talked about, VDR. So the backend or VPCC elements collect information from all your fleet to provide reports, to provide visibility, how your cars are being attacked, what are the hottest spots, in different countries or different places on the globe that are most vulnerable to such stealing techniques. And most importantly, we report that to an SVR, for example, stolen vehicle recovery system, fleet management, car owner, whoever needs to know about it, and we prevent it. That's the biggest difference between us and almost any other solution in the market. Most solutions today are GPS based, meaning they can only detect, and they detect way too late. The car is already driving. They are looking for an anomaly. For example, the car is driving to a new city. It was never driven to that area before. So maybe something happened, but maybe. The probability of that car being stolen is unclear. So the fidelity of the detection is unclear. And it's already too late because you discover it maybe 30 minutes, an hour after it was already stolen. So too late. The only option is to recover. But because we have presence in the car and because we can detect immediately, we can actually prevent the attack. So when the thief is trying to unlock the doors, we will not let this command take place and we will prevent it. So the doors will stay locked. If the thief is trying to start the engine, we will not let it start. So the car will not be able to move. So we can prevent it in many cases. So I shared a couple of capabilities. There are more that we can share and we'll be more than happy to hear from you. But I also want to mention a little bit about who we are, because not all of you maybe know PlaxidityX. We used to be called Argus. We have already more than 70 million vehicles that we protect today that are on the road or on the way there. We are basically a trusted automotive partner since 2014. We've been around for more than 10 years with a lot of experience. We've carried hundreds of pen testing, threat analysis, risk analysis reports. We've supported more than 100 customers in building agents inside the vehicle, building the backend of analyzing the security threats and creating incidents, in building the tools to detect and also recommend mitigation ways for vulnerabilities inside your code. There is a lot that we do, and we've been in this space for many years. In fact, we are well recognized as an industry leader by Frost & Sullivan report that placed us as leaders in this market. We are the chosen partner for Microsoft and Google and Deloitte that are providing services on top of our technology to our customers. And we even recently won the Automotive Competency Award from AWS as one of their strategic partners for the automotive space. And as I mentioned before, a couple of times, I told you that our IDPX solution are very well known as to be very high fidelity with no false positives. This has been verified several times by third-party benchmarks that found us again and again as the top solution in the market. So with that, I wanted to leave enough time for questions.
Thank you, Ran. A great presentation. Reminder to the audience, you can submit questions using the Q&A box. It's the little square with a question mark on it down on the bottom right. We'll give a couple of seconds to see if any come in, but in the meantime, Ran, perhaps you could just say, like, is there a like a key point that you'd like the audience to take away from your presentation?
Yes, thanks. So I think, as I started it, it's the right time. I think that up until now, our industry was very much focused on compliance. That was the only driver. But we ended up paying a lot of money and getting basically almost nothing in return. Just the checkbox of compliance we can meet UNR 155. But that's not enough. If you already pay and spend the money, why not spend less, meet the compliance checkbox, but also get real security? Because at the end of the day, we start to see cyber attacks. Year over year, we see more and more attacks. That's the right time, and we're here to help you, and we'll be happy to have this discussion with you and show you how we can help you achieve that in a reasonable time frame and a reasonable cost.
Looks like we might have received a question here. Does your system meet with the global data privacy norms?
Of course. So there are multiple ways to deploy our solution as a full software as a service solution where we maintain SOC 2 benchmarks and everything that is required because we run on public clouds. But we can also deploy that within your environment. Therefore, all the standards and the regulations that you are expected to meet, we will meet them as well. Information is encrypted. Everything was built with privacy in mind, of course.
And I think that might be all the questions we're going to receive. You've obviously explained the topic very well, Ran. So in that case, we'll bring the webinar to a close. I'd like to thank Ran for sharing his insight with us today. Thank you to PlaxidityX for making this session possible. And of course, thank you to the audience for joining. This has been session 3 of the Mobex Software Defined Vehicle Connectivity Summit. Goodbye. And again, thank you very much.
Thank you.